Ever get that feeling, when you're staring up at the night sky and it just hits you like, how much is out there? Billions of stars, galaxies, planets.
It's awe-inspiring, isn't it? That's what hooks people on astronomy, that vastness, the mystery.
Totally. But it can be overwhelming too. Like, where do you even begin with all that there is to know about space? It's like trying to take a sip from a fire hose.
Exactly. That's where we come in, right? With this deep dive, we're tackling some seriously cool astronomy lectures.
Distilling that cosmic knowledge into something a little easier to digest, like remember back in school how rainbows were this cool thing after a storm? Turns out there's some hardcore physics going on behind those colors.
Absolutely. Rainbows are all about how light interacts with water specifically, how light bends or refracts when it passes from air into water.
Okay, refraction. Tell me more.
So different colors of light actually bend at different angles. Violet light bends the most, red light the least, and everything else falls in between.
Ah, so that's how we get that classic ROIG by V rainbow pattern in the sky.
Right. The light bounces around inside the water droplets, gets refracted again as it exits, and boom, you've got yourself a rainbow. It's like a little prism effect happening in the atmosphere.
Amazing. See, I always thought rainbows were cool, but now I can appreciate the science behind them too. But okay, rainbows are one thing. What about seeing even further out, past Earth's atmosphere? That's where telescopes come in, right?
Exactly. Telescopes are like our eyes on the universe, letting us see things we could never dream of with the naked eye. Think about Galileo. His observations with the telescope were revolutionary.
Yeah, wasn't he almost excommunicated for that?
He got in hot water, that's for sure. His observations challenged the church's view of a perfect, unchanging heavens.
All because he pointed a telescope at the moon, right? What did he see? Craters?
Craters, mountains, shadows. Basically, he proved that the moon wasn't this smooth, flawless sphere people thought it was. It had features, just like Earth.
Must have been mind-blowing back then. So telescopes, they're key for studying the cosmos. But to really get this whole space thing, we need to talk distance, and I don't mean miles.
We're talking light years. And that's where things get tricky for people because it sounds like time, but it's actually distance, the distance light travels in a year.
Right, but light travels super fast, so a light year must be, well, ridiculously far.
It's mind-bogglingly far. To put it in perspective, think about the moon. Light takes a little over a second to travel from the moon to Earth. So the moon is about 1.3 light seconds away.
Okay, 1.3 light seconds.
The sun, which feels way farther, is about 8.3 light minutes away.
Wait, so sunlight takes over 8 minutes to reach us?
That's right. If the sun suddenly went dark, we would know for over 8 minutes. Spooky, huh?
Yeah, that's, wow, that's both really cool and kind of unsettling at the same time. And to think we're just getting started, 8 minutes for sunlight to reach us. It really puts things in perspective, doesn't it? Like, we're not exactly at the center of everything.
Not even close. Speaking of which, let's talk about our cosmic neighborhood, the solar system. Formed, what, like 4.6 billion years ago? Those numbers are always mind-boggling.
It's hard to even grasp, right? Like, the Cambrian explosion, when life on Earth went nuts, that was, what, 550 million years ago? Dinosaurs bit the dust 65 million years ago, and those feel ancient to us.
Ancient to us, but a blink of an eye on the cosmic timescale. And the distances between everything out there, it's not like things are all crammed together.
Yeah, spaces mostly. Well, space, as they say.
Right. Here's a thought. Imagine shrinking our sun down to the size of, say, a period at the end of a sentence. On that scale, the nearest star to us, Proxima Centauri, would be about 14 kilometers away.
14 kilometers, so like a decent bike ride. And that's the closest star.
Exactly. Space is mostly dot emptiness.
Yeah.
But each of those stars we see, they're like our sun, just incredibly far away. Many probably have their own planets and everything.
Okay, now my mind is officially blown. So we've got stars everywhere. But how do they even form in the first place? It's not like a cosmic light switch just flips on, right?
Huh. I wish it were that simple. Stars form from these massive clouds of gas and dust called nebulae. We're talking QGE, like spanning hundreds of light years sometimes. And they're not just sitting still, they're swirling, moving, kind of chaotic.
So like within those clouds, there are denser spots. Are those like the seeds of stars?
You could say that.
Yeah.
Over time, gravity starts pulling everything in those denser regions inwards. More and more material gets pulled in, the cloud collapses.
Where gravity is basically the sculpture of the cosmos then.
Exactly. And as the cloud collapses, it starts spinning faster, kind of like when a figure skater pulls their arms in. This spinning flattens things out into a disc shape, and at the very center, where all the gas and dust is getting crushed together.
Things are heating up, I'm guessing. Friction, pressure, all that.
Oh yeah, it gets crazy hot, millions of degrees. Eventually it gets so hot and pressurized, nuclear fusion ignites. Hydrogen atoms smash together, form helium, and release a crazy amount of energy.
That's the star turning on, right?
Bingo. It's now generating its own energy, shining bright. That's what our sun's doing right now, fusing hydrogen like crazy. It's what powers life on Earth, but nothing lasts forever.
So what happens when a star like our sun runs out of fuel? Does it just go dark?
That's where it gets really interesting, because stars have a life cycle, and it's often pretty dramatic.
Dramatic, huh? Okay, so lay it on me. What happens when the sun's gas tank is running on empty?
Well, in about 5 billion years, give or take, it'll start to run out of hydrogen in its core. That's when things get interesting.
Interesting, bad.
Or
Interesting.
so the sun gets really big. See, without hydrogen to fuse, the core starts to shrink under its own gravity. But here's the kicker. While the core shrinks, the outer layers, they actually expand outwards. Becomes what's called a red giant.
Okay, yeah, red giant definitely sounds like a warning sign. How much bigger are we talking here?
It's wild. The sun, as a red giant, could get so big it might even reach out to Earth's orbit. Mercury, Venus, gone, engulfed.
Yikes. So much for retiring on Venus. Okay, but seriously, the sun, the thing that keeps us alive, is going to eat a couple planets.
Metal, right. But hold on, there's more. After the red giant phase, the sun starts to shed those outer layers. Kind of like a dot cosmic butterfly coming out of a cocoon.
And that creates, wait, a nebula.
Exactly. That glowing cloud of gas and dust that's a planetary nebula lit up by the leftover core of the star. They're incredibly beautiful to see.
And at the center of that beauty is what's left of the sun.
That's right. Becomes a white dwarf. Imagine this. Earth-sized, but so dense, a teaspoonful would weigh tons, literally tons.
Okay, hold up. So the sun, this giant ball of fire, shrinks down to the size of Earth but gets insanely heavy. That's some dense stuff, no pun intended. That's it for stars like our sun, then. White dwarf retirement plan.
Pretty much. But the bigger stars, oh, they go with a bang. Literally supernova.
Supernovae, yeah, I've heard of those. They're insanely bright, right?
Some of the most luminous events in the universe. For a little while, a supernova can outshine an entire galaxy. The energy released is just mind-blowing, doesn't even cover it.
What causes that? It's not just a big star exploding, is it? There's got to be more to it.
You're right, it's more complicated. Basically, a really massive star, when it runs out of fuel, its core collapses so fast, so violently, it sends a shock wave that rips the whole star apart. Outer layers blast out into space at incredible speed.
Intense. So what happens to the core after that?
That's where things get even wilder. Sometimes it collapses down into a neutron star.
A neutron star. Okay, why do I feel like that's not going to be on any postcards?
Imagine this. About 20 kilometers across. Tiny, right. But it has the mass of our entire sun crammed into that space.
Denser than a white dwarf, even? How's that even possible?
It's basically a giant atomic nucleus, almost all neutrons. Gravity so strong, a teaspoonful of that stuff would weigh billions of tons back here on Earth.
Okay, now you're just messing with me. Billions of tons. A teaspoon. Come on.
And it gets weirder. Sometimes, if the star is massive enough, the core collapses even further, becomes an infinitely small point, a singularity.
A singularity. Wait a minute. Are we talking black holes now?
Ding, ding, ding. A black hole is basically a singularity, but around it is this region of spacetime where gravity is so powerful, nothing escapes, not even light.
Black holes. I mean, where do you even start with those? They're like the ultimate cosmic enigma.
They really are. Used to be just a theory, something predicted by Einstein's work on relativity.
And now we know they're real. We've seen them.
We have evidence, yeah.
Yeah.
Stars orbiting these invisible objects, so massive, so small, they can only be black holes. A few years back, remember, astronomers even got an image of a black hole shadow.
I still can't wrap my head around that. You know, it's amazing. We started with rainbows, and now we're here talking about black holes, stars being born, dying, those nebula clouds, neutron stars. It's all happening out there right now. Makes you feel pretty small, huh?
It does, doesn't it? And honestly, we've barely scratched the surface. The universe is full of these mind-blowing things. Galaxies, dark matter, dark energy. We've got a lot to learn.
That's kind of exciting, though, isn't it? All that unknown.
Absolutely. That's what makes astronomy so amazing. It's all about discovery. Every new observation, every new theory brings us closer to understanding our place in this vast cosmos.
Well said. So as we wrap up this deep dive into the universe, what's the one thing you hope people take away from all this?
That sense of wonder, that curiosity. Look up at the night sky and let your mind go wild with possibilities. There's so much out there waiting to be discovered.
Couldn't agree more. And hey, maybe one of our listeners will be the one to make the next big astronomical breakthrough, right? Until then, everyone, keep looking up.